there's your circuit diagram. What's wrong, Andy? I'm doing a good job? That's great. What?
He's Kirchhoff.
Yep, it is. Oh, Kirchhoff's, not good job, sorry. Here is R2, and here is a lamp of 4 volts and 12 watts. And here is a lamp of 12 volts and 6 watts. And then here's a resistor. So the first thing I'm going to do before I even look at the question is change those lamps into resistors. And you're also told that the lamps are operating normally, meaning that they are using a 6 and a 12 watts of energy. Okay. So let's see. What formula could I use here? I could use just P. No, I want P equals I squared R. So R would be P over I squared. So the resistors would be P, so 12 over 4 squared. So that's 0.75 ohms for that one. And then the other one would be 6 over, sorry, teacher do bad. Bad teacher. Bad teacher. I don't know the I. So I should be using this here. P equals IV and V equals I over IR. And I have the V and I have the P, but I want the or. Actually, because the first thing, yeah, no, I'll do it anyways. So P over V equals I from the first one there, and then I can put that into the second one. So I get V equals P over V times R. So then V squared over P equals R. Okay, so now I can write the resistors in. 4 squared over 12. Sorry, I'll go down if you need to see it. So this one here would be 4 over 3 ohms. And then the other one will be 12 squared over 6. So this one here will be 24 ohms. So let me redraw that again, but now make them resistors instead of light bulbs. So this one here is R2. This one here is 1.33. This one here is 24. This one here is R1, and this one here is 36. Okay, let's use Kirchhoff. So here, current is going this way, so that's I1, 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 I1. But then here it splits. So going down the center here, I'll call it I2, and then going this way, I'll call it I3. And then they recombine here to go back to being I1. That's I3. So Kirchhoff's loop rule. 36 minus V equals IR, so the voltage here again IR, so minus I1 R1. I'll go around the outside loop, minus 24 times I3, and then back to the battery equals 0. Now if I do the inside loop here, 36 minus I1 R1 minus I2 R2. Actually, I'll just put them together as one resistor, R2 plus 1.33. If you want, equals 0. Or keep them separate, I don't care. Yes, what's the unclear part? Yep.
It's IB until here, and then I4.
I'll show you here. It starts I1, and it's I1 all the way to here.
Okay.
Then it splits. I2 down this piece,
Yeah.
and then I3 around this piece.
What is 24?
24 was the resistance in this one. I used this formula to get it, because I know the V, and I know this one here. Actually, you know what? I don't need Kirchhoff, because I know the voltages in each of these, so I can just use Ohm's law. So if I look at this one here, I have V equals I or. What's the V here? 12. What's the or? 24. So I can get I equals V over or, which will equal 12 over 24, which is 0.5. Yeah, no, I'm going to get this one here. So this one here is 0.5 amps. Now, that's actually what you said, Andy, the I3. Okay, so that answers nearly the first part. We now have to get it for the other one as well. So this one here, again using Ohm's law, I is V over or. So I will be V, which is 4, over or, which is 1.33. So 4 over 1.33. So looking at this piece, I'll get 3 amps. So that means what did I call this piece here? 2, wasn't it? I2 equals 3. Okay, so that answers part 1. Now part B, oh, I've actually done part B. Alright, so I'm finished now.
I2 you really can find.
Huh?
The I2 because that is R2.
The I2, what? The I2 will be the same in the R2 and the lamp, yeah.
So you have to get both the resistance and you can.
I've actually done everything they asked. They wanted just the currents in each lamp. Yeah. And they wanted the resistance in each lamp, which is what I did first. Oh wait, but then we have to calculate the value of R1 and R2 as well. Alright, so how can I get R1 and R2? So I need 2 equations if I want to get R1 and R2. Alright, so now I can't divide it, I have to use Kirchhoff. Okay, so let me just, did you make note of those I's? Okay, so let me draw the diagram again. Okay. Now do we know the I1? We don't. Okay, so there's I1. Do we know the I2? We do. What did I say the I2 was? What is it? 3. Okay. This one here is 4 volts. And you know that the current you said is 3. Okay, and then finally this one here, this is 12 volts. And you know the current is, did we know this one, this I3?
Yes.
Yeah, what is it? 0.5, thank you. Okay, so let's use Kirchhoff's now, the loop, the battery, and we'll go outside. So 36 minus I1 R1 minus 12, because I know this is 12 volts, equals 0. Now let's do the inside loop. 36 minus I1 R1 minus I2, so minus 3 R2, this is I and R, and then minus 4. Okay, this is enough information to give me the R2, because if I subtract these equations, they cancel, I'm left with 12 plus 3R2 plus 4 equals 0. Minus 12. Okay, 12 minus 4 divided by 3. So I get R2 equals 8 over 3, 2.67. Right. Well, I'm going to finish in a moment if you want to see the end.
This one.
Yeah, just one last one to do, which is to get the R1.
You substitute.
Alright. I guess you really need to go. Now, to get the R1, I could use Kirchhoff's rule again. What rule have I not used? I haven't used the junction rule. But also, I haven't used Ohm's law as well. So you know Ohm's law says V equals IR. Maybe I won't use that. Okay, maybe I'll do what Andy just said. If I put this in here, yeah, alright, I'll put that in there. So I get 36 minus I1 R1 minus 3 times R2 minus 4. So that'd be 0. So I'll end up with saying I1 R1 equals 32. Well, that's actually the same as that one there. That's also I1 R1 equals 32.
3R2, you didn't.
Here? Oh, that's because I put the number in.
Yeah, but you didn't.
I did 3 times this number minus 4. Oh, that's strange. Minus 3 times 2.87 minus 4. That should have been, oh, sorry, I'm wrong. 36 minus I1 R1 minus 3 times 2.87 or 67 minus 4. Yeah, so actually, yeah, that's minus 4.
Minus 3 multiplied to
2 point, sorry, that's 67.
It's minus 8.61. Then we multiply to minus 4. Then we
minus 4.
Minus 4.
Yeah, minus 12. Sorry.
Minus 12.61.
I think this is 6.7 I got here. I think you might put an 8.7.
6.7?
Yeah, sorry about that. Equals 0. So I get I1 R1 equals 24. But you could have gotten that result from that one there anyways. Okay, now I haven't used actually Kirchhoff's junction rule yet, saying the current that goes in must match the current that comes out. So what current is going into this junction here? I1. And what current is leaving it? I2 and I3. So what was I2? Is 3. And what was the other one? 0.5. And that should equal 0. So that gives us the I1, so then we can get the R1. We get I1 equals 3.5. So then we get R1 equals 24 divided by 3.5. So that'd be 6.86. Okay.